We are going to begin the transition from the PowerPC to Intel processors, and we are going to begin it next year.
In 2006, Apple began the process of transitioning the Mac from PowerPC to Intel CPUs. Apple did this because Intel's performance offering was far superior to PowerPC, all while consuming far less power and producing far less heat. The Intel transition also meant that, for the first time ever, PCs and Macs used the same CPU architecture, which meant that Macs could run Windows. In fact, through the entire lifespan of the Intel Mac, Apple officially supported this. Boot Camp Assistant, a program bundled with Intel Macs, allowed you to install Windows, including all necessary hardware drivers, on your Mac. Boot Camp allowed for apps and games not compatible with Mac OS X to run on Macs, without emulation, for the first time since those weird PC-compatible cards from the 90s that had an actual Intel 386 on them. Boot Camp was a major perk of the Intel architecture, especially towards the beginning, and was even advertised in one of the famous Mac vs. PC ads.
Hello, I'm a Mac.
And I'm a PC.
And I'm a PC too.
And what?
Yeah, see, now you can run Mac OS X or Windows on a Mac. So in a way, I'm kind of like the only computer you'll ever need. You can get a Mac and still run all your Windows stuff.
Hold on, why is the corner blurred out? Wait a second. This isn't an ad for Boot Camp, this is an ad for Parallel.
Now, I'm sure you're wondering, why on God's green earth would Apple make an advertisement where they say you can run Windows on Macs but mention a third-party virtualization product instead of their own solution? Well, when I said that Boot Camp existed through the entire lifespan of the Intel Mac, I lied.
The first beta version of Boot Camp didn't land until April 5th, 2006, over 3 months after the first Intel Mac, and the stable version didn't land until over a year later with Leopard. Parallels seemingly didn't even exist until June of 2006, so I guess when this ad came out, Apple understandably didn't consider Boot Camp stable enough for mass adoption. This newer version of the ad that doesn't mention Parallels all but confirms my theory.
But before Parallels, before Boot Camp, before anything official existed, there was a secret, more complex, third thing.
And no, to the 26 people who already commented this, you couldn't just insert the XP disk into the drive and hold C until a firmware update released at the same time as Boot Camp.
This is the story of XOM, the time two hackers did the impossible and brought Windows to the Mac before Apple.
On January 22, 2006, 23-year-old blogger Colin Nadercorn began a contest to develop a way to get Windows XP running on the new Intel Macs. At first, the contest page read simply, "My new Apple MacBook is shipping on the 15th of February. I told my boss that this would replace my IBM desktop and I could boot Windows XP on it. I am still confident it can be done. I am giving $100 of my own money and offering anyone else who would like the instructions on how to dual boot these two operating systems the ability to give some of their money into the pot as a prize for the person/group that can make dual booting Mac OS X and Windows XP happen on an Intel Mac. Good luck, Colin." Over $10,000 were raised within the first 2 weeks. News of the contest and the cash prize spread quickly, being covered by outlets like Ars Technica. A forum sprung up, and dozens of developers joined to share ideas on how to get Windows running. I wish I had more examples of this, but unfortunately, almost none of the forum is archived.
The Wayback Machine seems to have had an issue archiving sites with ampersands in the URL back then, so almost all of the pages are either mostly or completely inaccessible, being replaced by thousands of identical error pages.
I had to use the Wayback Machine's very rudimentary and slow search feature to find the threads that I did, and even then, much of the content in them is either locked to registered users or missing.
Days turned into weeks, and weeks turned into a month with no solution. Donations slowed down, and interest began to die out. Some users even thought that it was impossible. The differences between Macs and PCs were just too numerous, and Windows would never run on the Mac platform. That was until Monday, March 13th, 2006.
A user by the name of Narf2006 made a post to the forums with an image of an Intel iMac displaying Windows XP. Users were skeptical at first. After all, it's pretty easy to just take a photo of XP and use Preview or something to display it on the iMac. It's also admittedly pretty hard to see what's going on in this awful 2006 cell phone photograph. Looking through the old Flickr account, we can see various tests and progress updates through late February and early March. which seemed to be cross-posted to now deleted forum posts.
3 important things happened over the next couple of days.
A video of Windows XP being installed on and running on an iMac was uploaded to YouTube and Vimeo. The binary and source code for the solution was shared with the forum, and the identities of the 2 hackers were revealed as Bay Area-based developers Eric Wasserman and Jesus Lopez Amaro. Wasserman introduced Lopez to the project and posted a lot of the progress updates on his accounts, while Lopez did seemingly all of the actual programming. After Colin Nadercorn and some forum regulars verified that their solution was legit, it was posted publicly under the name XOM at onmac.net.
The final prize money won by the 2 developers was $13,854, or adjusted for inflation, $22,885. Not too shabby.
When XOM was released, tech blogs, podcasts, and even mainstream news covered it extensively. It even landed itself a spot on the now long-forgotten New York Times Circuits video series.
Check out my new Windows XP computer. Yeah, looks a lot like a Mac, doesn't it? Looks like a Mac Mini. 'Cause it is.
Just a quick tangent here. This series was originally hosted on Google Video. Not YouTube, mind you, Google Video. And I had to dig through a 3.7 gigabyte CSV file to find the upload. The episode about XOM is archived on my 3rd channel now, so if you want to see the whole thing, check there. Interesting time capsule. Now that we've gone over all that history, let's check out what was actually submitted, shall we? This is an original Mac Mini. It has nearly all of its original specs. A 1.66 GHz 32-bit Intel Core Duo processor, 1 GB of DDR2 RAM, 120 gigabytes of mechanical storage, and an integrated GMA 950 graphics card.
XOM does not work on any Macs newer than this Mac Mini. It only supports this computer, the early 2006 Core Duo iMacs, and the early 2006 Core Duo MacBook Pro. Every other machine, including the white MacBook and later Intel Macs, does not work with XOM, leaving Apple's official solution as the only option.
Of course, all of those machines had the firmware update that let you just boot Windows CDs by holding C, so no big loss there. To install XOM, we first have to boot from the original macOS X Tiger install media, open disk utility, and create 2 partitions, one for Windows and one for macOS X.
Tiger's version of disk utility did not support resizing partitions, even unmounted ones after they had been created, so the drive has to be completely wiped.
The first partition, for Windows, must be FAT32 formatted, and the second, for macOS X, must be HFS Plus formatted. Tiger can then be installed as usual.
These days, it's allegedly really easy, I heard, to find copies of Windows XP online. But back in the day when Microsoft was still selling it, they were far more likely to take things down.
For that reason, XOM doesn't redistribute patched Windows XP ISOs, instead requiring you to own a real copy of Windows XP Service Pack 2. No earlier or later versions will work, and patch the disk yourself. And yeah, we do need to patch XP a little. The README has some pretty detailed instructions on how to do this. Basically, we need to copy the files on the CD to CXP on a Windows XP computer, then use Nero Burning ROM to patch the CD with a custom video driver, we'll get back to that later, along with the Intel SATA drivers because Windows XP doesn't natively support SATA. We can then burn the completed CD to a blank disk, but we have to do one more step before we can boot from it. Back on the Mac, we need to copy xom.efi, the magic file that makes Windows booting possible, onto the hard drive. Then we can use the terminal to bless it. Upon rebooting the Mac, we are presented with a new menu allowing you to select between Windows and macOS X. We can use the up and down arrows to switch between the 2 operating systems and enter to boot Windows, but before that we must insert the patched Windows XP CD into the Mac. Once we select Windows, a lot of lines scroll down the screen, but eventually we get to the pretty standard Windows XP installer, where we can choose that FAT32 partition we made earlier and go through the installation as normal. Because these machines are pretty fast, we get to the desktop within 20 minutes or so. Hold on a second. What we just saw happen on this Mac Mini should not be possible. And to explain why, I need to give you a brief history lesson.
Until about 15 years ago, virtually all PCs used what's known as the BIOS, or Basic Input-Output System, for their firmware.
The BIOS was first introduced with the IBM PC 5150 in the early 80s, and is stored on a ROM chip on the motherboard. The BIOS has performed roughly the same basic tasks since then: set up and test the RAM, set up devices, show a nice pretty logo or some text on the screen, scan for disks, and execute what's known as the boot sector, or the first 512-byte sector of the boot disk.
This code is the first non-firmware that the CPU sees in a BIOS-based computer, and must run in 16-bit real mode, the most basic and oldest operating mode of the x86 architecture. Real mode has numerous disadvantages compared to the newer, and by newer I mean mid-80s, protected mode, such as the lack of memory protection, the inability to address more than 640 kilobytes of RAM, and the lack of support for 32-bit and 64-bit modes.
Since 512 bytes of code is not much, all that's usually done by the boot sector is load an additional, much larger set of code, known as the bootloader, that performs tasks like printing out a menu or some logs to the screen, and eventually booting an operating system.
At this stage, doing basically anything involves using something called BIOS interrupt calls.
I'm oversimplifying this a bit, but an interrupt is a signal sent to the CPU telling it to stop what it's doing, run some code, and then go back to whatever was going on before. There are different types of interrupts, and they can be triggered by devices like a keyboard or mouse, by exceptions like dividing by 0, and through x86 assembly's int instruction. But all we care about is that last one. That's what BIOS interrupt calls are.
When you turn on your computer, the BIOS sets up what's known as the IVT, or interrupt vector table, and fills it with interrupt handlers, or pointers to code that is called when an interrupt is triggered.
These are numbered and are the most basic pseudo API that the PC has, and they can be used for very basic, very rudimentary control of I/O. Print to the screen, int 10 hex. Read and write to the disk, int 13 hex. Use the keyboard, int 16 hex. These must be called when the CPU is in 16-bit real mode, and are used by bootloaders in order to load an operating system and its much more sophisticated hardware drivers.
With the exception of DOS, which uses them for everything because it's ancient, BIOS interrupts are really only used for setting and getting video modes. We'll get back to that later, once you're in an actual OS.
But times have changed since the days of the IBM PC. Gone are the days of bootloaders and OSs fitting in 512 bytes and running entirely in 16-bit real mode. Gone are the days of DOS being relevant to anyone's life. Gone are the days of RAM and ROM sizes in the kilobytes. By the mid-90s, Intel knew that BIOS as a standard was on its last legs, so they began the development of the Extensible Firmware Interface, or EFI.
Originally developed for Itanium computers, EFI serves a similar purpose to the BIOS. Set up the RAM, set up devices and peripherals, show a pretty logo, scan for disks, hand things off to the bootloader.
However, since EFI was first being developed in a time where computers had megabytes, not kilobytes of RAM and ROM, a lot more could be done. First of all, EFI runs in either 32-bit or 64-bit mode depending on your processor. Instead of using interrupts, which could only be directly called from real mode assembly, EFI uses tables of functions and protocols easily callable from modern C code. Want to print to the screen? Use the console out functions. Input from the keyboard, console in functions. Read from the disk? Good news, EFI knows what files are. No more messing around with boot sectors, although you can still get direct block access to the disk if you so desire.
As the name suggests, EFI is also extensible, meaning that anyone can pretty easily write a driver to add support for some hardware or a file system.
Drivers implement protocols which can be located after the driver loads by using the locate protocol boot service. From there, it's just more tables of functions. Want to get information about the screen? Locate the graphics output protocol by its GUID using the locate protocol boot service, then call a function in the return table to get and set video modes. Instead of reading from the boot sector, EFI typically looks for boot files in some predetermined locations, as well as any location saved by operating systems in the NVRAM on FAT32 partitions.
These files, known as EFI applications or drivers, are basically the same thing as EXEs, or the same executable format as EXEs, and are a lot easier to program for than x86 assembly. In the legacy BIOS world, you have to write a pretty decent amount of assembly, including a lot of 16-bit assembly, whereas in the EFI world, you don't have to write any 16-bit code or assembly.
After the Titanic sank in the early 2000s, EFI kinda sat around in a few years. Some of the first machines to use this standard were Intel Macs, which used EFI from beginning to end.
Apple was all in on EFI in the late 2000s. It even made its way onto the iPod Nano of all places for a few years.
PCs got EFI too, in the form of the more polished and complete UEFI standard, starting in the early 2010s, with Microsoft adding full support for the standard in 2012 with Windows 8. Older OSs like Windows 7 could still run on UEFI-based computers through the use of the CSM, or Compatibility Support Module.
I'm oversimplifying again, but the CSM allows older OSs to still work on EFI-based machines while the industry transitioned from the old standard to the new one.
Many desktop motherboards being sold today still have a CSM, but most laptops and pre-built machines stopped shipping with a CSM around 2019 or so. And almost every computer sold today is UEFI only by default.
That also means that anyone that says that I'm going to the BIOS menu on newer computers is a liar, who should have no credibility and should be immediately canceled. I'm kidding, of course. Everyone knows what they mean. But BIOS is no longer correct, okay? But you know what does need BIOS? Windows XP. Windows XP does not support EFI. Well, technically, there was a version of both Windows Media Center Edition and Windows Longhorn that supported it, but those don't count since they both require a CSM to be present even though they aren't exactly booting with it. The Itanium version of XP is the only version of XP to officially support EFI without CSM, but Itanium doesn't exist. It's a conspiracy made up by Clippy to So like I said, no version of Windows XP supports EFI without a CSM. When XOM was being developed, Macs didn't have a CSM, so while there was some speculation on the usefulness of the Longhorn or Media Center loaders, no one could get them to actually work.
Even when Macs did get a CSM with Boot Camp, they still didn't work because Apple's CSM works differently from literally everyone else's. Think different.
Doesn't matter though, because XOM doesn't use the Longhorn or Media Center loader to boot XP.
Now, those of you who know about me know that I ported Windows XP to the original Apple TV, and you might have been wondering this whole time whether the approach XOM took was anything like what I did. The answer is not really. My approach uses a port of Freeloader from ReactOS to load Windows. This approach works great today, but Freeloader was in its infancy in 2006 and probably couldn't reliably boot Windows XP yet. Even if it could, it didn't support EFI at all until a few years ago, and booting XP on EFI wasn't possible until some changes I merged literally this year. Freeloader also can't boot Windows CDs, whereas XOM does so just fine as long as you patch them.
But that's not all. Not only is the firmware on these Macs incompatible with what XP requires, the disk partition scheme is too.
Windows XP requires the MBR, or Master Boot Record, partition scheme, which originated sometime in the 80s to allow hard drives to have more than one partition.
However, by the time the 2000s rolled around and the price of storage significantly fell, the MBR started to show its age. It only supported up to 4 partitions, and while extended partitions allowed for more than that, it still had the major flaw of only supporting disks up to 2 terabytes in size.
For this reason, when Intel was developing EFI, they created the GPT, or GUID partition table, which fixed literally all of these issues. Of course, it was not backwards compatible with MBR, so OSs would need to be modified to use it.
Windows didn't support it until Server 2003, and even then, it didn't support installing to GPT partitions until much later. And while Intel Macs will boot EFI OSs from MBR disks, macOS won't actually install on anything that isn't a GPT. So yeah, Macs didn't have a CSM, the disk is set up wrong for Windows, XOM doesn't use the Longhorn loader, it doesn't use the Media Center loader, and it doesn't use Freeloader. So how does it work?
Well, the code was archived on Colin Adercorn's GitHub in 2011, so let's take a look at it to find out.
12 seconds later.
Okay, none of this makes any sense. This is even more cursed than I expected. What? Why did they do this? How is Windows okay with... Before we talk about the really cursed stuff, I'd like to discuss probably the least weird thing that XOM does, that being the disk setup. To prevent data loss from GPT drives being possibly misinterpreted by older OSs like Windows XP, Intel made it so that nothing about GPT directly conflicts with MBR.
For that reason, it's totally possible to just have a disk with both an MBR and a GPT, provided that that disk doesn't have more than 4 partitions and isn't larger than 2 terabytes. I mean, even if it does, it just won't let you access anything past that point. XOM is the first implementation that I know of something called hybrid MBR, or as the incomplete wiki calls it, MBR mirroring.
This is almost exactly the same thing that Apple did with Boot Camp. The exact implementation seems to be a little bit different, but it's yet another thing that Apple was beat to by XOM.
Though I would be remiss not to mention that Clay McClure, another person going for the cash prize, did a very similar thing in his failed attempt at winning the XP on Mac contests.
So that means that 3 different groups came up with the same solution to the same problem. Pretty cool if you ask me. Okay, let's talk about the really cursed stuff.
The short answer to how XOM works is that it implements a legacy BIOS on top of UEFI, which is essentially CSM in software rather than in firmware. The code even calls the implementation CSM once. You might be wondering if this bears any resemblance to CSM Wrap, a project that does a similar type of thing but targeting more than just Windows XP.
The answer is no. CSM Wrap loads CBIOS, an open source complete BIOS implementation mostly used by emulators like QEMU, whereas XOM has its own BIOS implementation that's just enough to kind of boot Windows XP Service Pack 2 and not much else. And I do really mean just enough. Basic things like printing to the screen don't even work correctly.
When Windows XP's bootloader calls a BIOS interrupt, it gets transferred to the XOM interrupt handler. This handler switches the CPU into 32-bit protected mode, calls an EFI function that does a similar thing to the BIOS interrupt that's being called, does whatever conversion is needed to ensure that the data is set up in a way that XP expects, and then switches the CPU back into 16-bit real mode.
Now, those of you who know about EFI programming, which I kinda doubt, but you never know, might notice something a little off here. Normally, before an EFI bootloader hands off control of the system to the OS, it has to call the exit boot services EFI service. This unloads all EFI drivers for things like USB and transfers control of the full memory space over to the operating system. This is required because literally every operating system needs to have the lowest level control possible of the memory and all the devices.
And it's pretty much impossible to switch back into EFI boot services once you get out of it. Naturally, exiting boot services breaks literally every EFI function used by XOM's interrupt handler. So how did it compensate for this?
The answer is so wild that I didn't even believe it the first time I saw it. XOM never calls exit boot services. The issues in Windows land that not calling this could cause are numerous. Devices like USB controllers are not supposed to be initialized when Windows first starts. I'm also surprised that Windows can correctly set up the memory management unit, since EFI seems to set that up in its own way too. But now that I think about it, it kinda makes sense that everything works. The bigger issue would be calling boot services while Windows is booted, since whatever hardware the boot services use would be in an unexpected state since Windows messed it up, but Windows doesn't really set up any hardware until after the NT kernel is loaded. And after the kernel's loaded, it only calls one BIOS interrupt. We'll get back to that. Don't get me wrong, it's still cursed, and I'm still surprised it works as well as it does, but I'm sure that some OEM shipped a BIOS that leaves the machine in an even more cursed state. Things like the USB controller being in a weird state is also a potential problem, but I'm sure some other computers have similar problems. And yeah, pretty much everything works fine on unmodified Windows. Well, besides one thing. You've been waiting long enough. It's time for me to talk about the video driver. Because if you think that what we saw before was cursed, you ain't seen nothing yet.
On legacy BIOS, the standard way to get information about the screen is through a standard known as VBE, or VESA BIOS extensions. To retrieve or set up a video mode, a special BIOS interrupt, int10 hex with 4F in the AH register, can be used. Of course, the interrupt itself can easily be emulated. Boot services themselves would probably be unhappy with how Windows set up the machine, but XOM just calls the video info service at the very beginning and saves the resolution information for later.
But there's still a problem. Every computer using legacy BIOS has several text modes and at least a few different graphics modes. whereas EFI-based machines never have real text modes, and in the case of early Macs, only have one graphics mode. This difference directly conflicts with the way that Windows' default graphics driver works.
Windows' default video driver, known as VGA.sys, supports VBE, but also assumes that your computer is a normal PC with the graphics modes mentioned previously. It also assumes that there is a working frame buffer mapped to a particular segment of memory, which there isn't on EFI-based machines. And while XOM does seem to enable this on the iMac and MacBook Pro's ATI graphics card, we just saw Windows working on a Mini without any issue.
Because there's no text modes or standard frame buffer, VGA.sys refuses to use the VBE mode that XOM sets up. There are really two ways to fix this issue. One is to reinitialize the card in legacy BIOS mode. This is what's done by CSM wrap, but it requires a video BIOS, which might have been somewhere in these Macs firmware, but no one ever found it or figured out how to use it back then. This is also the approach used by Apple's CSM implementation for Boot Camp. But unlike XOM's devs, obviously Apple can just ask ATI or Intel for help. The other, which is done by XOM, is to patch the video driver.
XOM ships with XOMDD.sys, a binary patched version of VGA.sys that removes the requirements for those default modes. That's the main reason why we had to patch the CD.
Despite Windows XP's initial setup phase being in text mode, it can run in graphics mode with its own built-in font if no text modes are available. I guess this was probably used to display setup on Itanium and earlier versions of Windows NT, with graphics mode only hardware.
But it is kind of cursed to see Windows XP set up in high resolutions and squarer aspect ratios than usual. But something still doesn't add up here. Look at this. When we boot Windows from a CD, right here, about 2 minutes into the boot process, we see something about patches being applied here. What is that about? To find an explanation, I looked to the archived XOM wiki. It's not particularly detailed, but it does mention something about a time-based patching engine.
Calling it this makes it sound a lot more high-tech than it actually is. When the BIOS call for extended get drive parameters, for some reason, is called by the bootloader on the Windows CD for the first time, XOM saves the timestamp of that call, as in like the actual time it was called based on the clock of the computer. Then, on every subsequent call to this interrupt, if it's been more than 2 minutes since the first time, XOM finds and patches the video driver in memory while the system is booting. Why? Why would you do this? Why wouldn't you just replace VGA.sys with the patched one? Why wouldn't you just patch txtsetup.sys to tell Windows to load the patched one like you already do so that the SATA drivers load? This is even mentioned on the wiki as a possible improvement. Why would you spend all that time implementing a whole routine that live patches the memory after 2 minutes when the driver is hopefully loaded by intercepting an interrupt and scanning the first 32 megabytes of system RAM looking for byte patterns, which are almost definitely Windows XP Service Pack 2 specific, to replace? What is the point of all of this? My only guess is that the video driver on the XP CD is digitally signed by Microsoft to prevent malware, which, I mean, they could have done that, but there's just so many other ways to fill a Windows XP ISO with malware, I just doubt it. Speaking of malware, this is beyond malicious. This is basically a highly sophisticated rootkit, not dissimilar to what DOS viruses actually did to evade detection. It just happens to not be a virus this time. Thank God Apple released a better implementation 2 weeks later and no one had to deal with. Okay, I need to calm down here. I feel like I was a bit mean there. I think I need to rectify that. I love XOM. The story, the implementation, the code, just everything. I love it. I'm just in awe of how this massive cursed pile of hacks manages to actually work. Mostly. And I do mean mostly. There are some things about XOM that don't quite work properly.
First of all, accelerated graphics. They don't work. Some people got them working on the Mac Mini, but I haven't attempted it since it seems pretty annoying. This is an issue with EFI Linux on at least the original 2 iMacs. To this day, the only way to get accelerated graphics on some early Macs is to install Linux or Windows in BIOS mode, which wasn't possible until the Boot Camp firmware update. 2D performance isn't terrible, and not as much used the graphics card back then, but yeah, gaming with XOM isn't really possible. The Mac Mini has its own issue too. You might have noticed that I swapped monitors from the shot where I installed macOS to the shot where I installed Windows, and this is why. The installer will freeze at the beginning of copying files and will never finish if your display resolution isn't 1280 by 1024.
This almost led to the cancellation of this entire video. I managed to install XOM once successfully off camera with the 1280 by 1024 monitor, then attempted to reinstall it on camera with a 1080p monitor, which of course didn't work. I spent hours troubleshooting this. I changed the order of the partitions, I replaced the RAM, I replaced the CD drive, I replaced the hard drive, I reburned the disk, all to no avail. A whole month later, while idly perusing the code one day, I had a thought. The one difference between the working and broken tests was the monitor.
Sure enough, after swapping that out, Windows installed like I'd never said a bad thing about it. This issue was actually fixed, but sadly the update was password locked and never archived. And judging by this video from MacBreak, the fix seems to have just been running XP in a 1280 by 1024 box in the corner of the screen.
So maybe it was for the better that it wasn't archived. 23 days after XOM's release, Apple announced Boot Camp, which makes me wonder, was Boot Camp developed in response to XOM? There's no way to know for sure, but I personally don't think so.
Apple was a multi-billion-dollar company in 2006, so I highly doubt they developed and released the whole thing that quickly with no bureaucracy.
My guess is that Boot Camp was probably in development maybe as a side project of a few people for Leopard before any of that, and when they saw the press that the XP on Mac contest had gotten, they pushed out Boot Camp as a public beta. One thing's for sure though, Boot Camp has overall been a success for Apple. Apple's stock price went up significantly in the day that Boot Camp was released. And while Apple's Windows drivers gained a much-deserved reputation for being unstable pieces of junk later on, in 2006, I'd say they were above average compared to other PC vendors. As software support for macOS improved, Boot Camp became less and less useful. And in 2020, with their Apple Silicon Macs, Apple said goodbye to Boot Camp forever.
You can still virtualize Windows on Apple Silicon, and there's even a few people working on a native port, but the era of official support for third-party operating systems on Mac hardware is over.
After Boot Camp, XOM was swiftly forgotten.
Boot Camp provided drivers for literally every piece of hardware that XOM didn't support, was much easier to use, and didn't require you to erase your drive.
I can find like maybe a dozen mentions of XOM since 2006, and the only two notable ones in the past 10 years are this interview from Jesus Lopez and Michael MJD's first Apple TV Windows video. But I made this video because the story of XOM deserves better than that. Huge hats off to Colin Nadercorn, Eric Wasserman, and especially Jesus Lopez Amaro for making XOM into a reality. I would love to interview them, or at least ask a few questions about XOM, but so far I haven't been able to get in contact with anyone except for Colin Nadercorn.
Colin, I meant to get back to you on Twitter about some interview questions, but I didn't have time to re-record the script to fit those in before going on vacation, so I'll get back to you later. Sorry about that.
No pressure at all, but if you are any of those three people, or anyone who did stuff with XOM, and are interested in an interview, my email is on my website and on my About page, and my social medias are linked in various places. If you've made it this far, thank you so much for watching. You can follow me on social media if you want, and if you're interested in original Apple TV hacking, I have a Discord for that now. If you'd like to see more content like this, be sure to subscribe, although I can't promise my upload schedule will get any better. Once again, thanks for watching, and I'll see you in the future.